Hello and welcome to our video presentation for EKC483. In this video we will discuss on the pressure swing adsorption process, PSA, in natural gas processing.
Okay, hi everyone, we are from Group 13. We will be presenting on pressure swing adsorption in natural gas processing. Okay, myself, I'll be presenting on the fundamentals of pressure swing adsorption. Introduction. Pressure swing adsorption is an adsorption-based process where an adsorbent selectively absorbs one compound known as adsorbate from a fixed mixture, thus achieving separation. So there are three mechanisms where PSA is used to achieve separation. Number one would be the thermodynamic equilibrium mechanism, where the separation is based on the thermodynamic state between the adsorbent and the adsorbate, which is in turn is a function of temperature and pressure. The steric mechanism, where the different adsorbate is separated based on their molecular size into the pore mouth of the adsorbent. The kinetic mechanism is where different types of adsorbate is separated via the different diffusivity rates into the pore mouth of the adsorbent. So next will be the important parameters used in PSA. One will be the selectivity. Selectivity is defined as the differences in affinities of the adsorbent for the different components in the feed stream. Equilibrium selectivity is generally expressed by the separation factor, which is a ratio of the Henry constant of one adsorbate to the other. Okay, regenerability. Regenerability is a measure of how easily we can regenerate the adsorbent. So ideally, we want to be easily regenerate the adsorbents. But regenerability is often a trade-off parameter in the design of the adsorption column because of the very selective adsorbents when higher energy requirements is needed to regenerate them. Okay, heat of adsorption. So as we know, heat absorption is a measure of the strength of interactions between the adsorbent and the adsorbate. Adsorption is usually an exothermic process where during adsorption, heat is released to the adsorption column. So ideally, when we want to regenerate our adsorption column, the similar amount of heat released during the exothermic step are needed to supply to the adsorption column so that we can regenerate them. So larger heat absorption indicates a larger energy requirements for regeneration. Working capacity. Working capacity is defined as the difference between the amounts of a component absorbed and dissolved at the condition of the adsorption and desorption steps, which is strongly influenced again by temperature and pressure. Okay, I would like to take a brief moment to introduce you the Scarstrom cycle, which is the pioneer of PSA applications in industries. Okay, the cycle involves four main steps. Number one would be the feed step, the blowdown step, the purge step, and the pressurization step. Okay, during the feed step, feed is directed into the adsorption column for adsorption process until the column achieves saturation. Okay, when the column achieves saturation, we proceed to the blowdown step. The blowdown step is where the feed to the first column is stopped and is rerouted to the next column for adsorption. So by doing so, we can open valve V5 and V3 so that the gas trapped inside the adsorption column is released via blowdown. So the next step will be the purge step. So why would we need to have the purge step is because the blowdown step would not be sufficient to entirely remove all the adsorbed components. So a purge step is where you introduce a purge stream into the adsorption column so that purge stream will carry the adsorbed component inside the batch stream coming out together with them. So the next one will be the pressurization step. The pressurization step is a step where you prepare the adsorption column for the next feed processing. So the pressurization step is easily achieved by redirecting air or nitrogen into the column, highly pressurized air or nitrogen in the column, inside the column until the column achieves the required pressure. Okay, there are a few modifications to this Scarstrom cycle that the technology that people have made today so that to make the PSA cycle a more feasible, a more economical and more attractive method for separation. For instance, during the Montario and Domin proposed vacuum regeneration almost at the same time as Scarstrom. The unit is renamed as Vacuum Pressure Swing Adsorption, or VPSA, when vacuum is utilized to regenerate the column. So when vacuum is utilized, the pressure inside the column will decrease below the atmospheric pressure, so that the highly selective component will be easily dissolved. So the next one will be the EXO Regeneration Research Group. They introduced a pressure equalization step in the late 1960s. Okay, so we go back to the diagram. Okay, so the pressure equalization step is where after the feed step, at the end of the feed step for pressure for the column number 1, and at the end of the purge step for the at the start of the purge step for the column number 2. So during this step, V5 and V6 simultaneously open, so that the blow down from the column number 1 is directed to the column number 2 for the purge step. So this saves the pressurized air unit for the purging of the adsorption column. Okay, I'll be passing the next presentation to Zulaika. Thank you.
Then I will present about adsorbent. Function for adsorbent is used to separate gases such as nitrogen and carbon dioxide from natural gas. Next, characteristic of adsorbent. First, a high selectivity of gas absorbent capacity for the target gas components. The second, fast absorption and disruption kinetics. Then, good physical and chemical stability through absorption and disruption cycles. Regenerable by modest temperature or pressure swings to minimize operating costs. And then show robust performance in the presence of moisture or other contaminants that may or may not be in the natural gas feed. Then low cost per unit volume, and lastly, reasonable packing density to avoid oversized vessel. An example for absorbent is carbon-based absorbents. First, it's popular absorbent currently employed in the energy gas industry. Advantage for carbon-based absorbent is able to perform separation and purification without requiring prior stringent moisture removal. And second, absorb more non-polar and weakly polar organic molecules than other absorbents do. And lastly, exhibit a low heat of absorption. Next, I will pass to Shafika to present. Okay, thank you.
Thank you, Ms. Leika. Now we proceed to pros and cons of PSA. There are several advantages and disadvantages of PSA system in industrial sector, which are including PSA plants has high. Here is the advantages. PSA plant has high enrichment of methane gases. Thus, there no need to provide a gas which has already been previously enriched in certain component. This system has low capital cost and also low maintenance cost requirement. Then the gas to be separated can be directly utilized for the pressure increase. Next, we move to the operation. PSA system operate at ambient temperatures and do not require any solvent for product recovery or adsorbent regeneration. Instead, PSA is well suited to rapid cycling to be efficient use of adsorbent repetitive, making the process more preferable in obtaining large throughput with small adsorbent bags. Besides, PSA has high purity of product, rapid shutdown and startup characteristic, lack of corrosion problem, the absence of heat requirement and pipe insulation and comparative straightforward operation. Here the advantages of PSA system. The limitation for strongly adsorbed species would require very low pressure for desorption and increasing unit operating costs. Besides that, desorbate only recovered at low purity. It is also not economical for large-scale operation since mechanical energy is usually more expensive than heat.
Thank you, Shafika, for the presentation just now. Now I will proceed on the part of application. So PSA is well applied in nitrogen rejection from natural gas. So what is nitrogen rejection? Nitrogen rejection from natural gas is separation process that selectively removes nitrogen from gas. Nitrogen rejection unit (NRU) is a system that involves the removal of nitrogen from gas. So why we need to remove nitrogen? First, we need to conditioning the natural gas. We need to remove inert nitrogen gas that take up the capacity in the pipeline. This can increase the heating value of natural gas, and in the industry, there are viable pipeline specification for nitrogen. So no more than 4% nitrogen is the most typical specification in natural gas industry. So pressure swing adsorption, known as PSA, is usually used in nitrogen removal. This is the most versatile of the nitrogen rejection processes. Consists two key mechanisms, pressurized and absorption, and the second is depressurization and desorption. So PSA in nitrogen rejection, the higher the pressure, the more gas is absorbed. When the pressure is reduced, the gas is released or dissolved. Different gases tend to have to be attracted to different solid surface more or less strongly. You can see from this graph, if the pressure is high, the desorption, the level of sorption is higher in CO2 than nitrogen. Okay, so this is what applied in the industry for nitrogen removal using PSA. So next, I will pass to Farouk to explain on the other application. Thank you.
Another application for PSA is in carbon dioxide removal from natural gas. So application of PSA in carbon dioxide removal is a mature technology that is well practiced around the globe by major energy players as a main alternative to cryogenic distillation. One of the earlier patents in this field, assigned to Union Carbide, now is called UOP, describes a PSA system based on a zeolite. Zeolite able to selectively absorb carbon dioxide from low quality natural gas. This system exploits displacement with carbon dioxide rinse to remove absorbed methane from zeolite bed and to purge methane from column void space. The high purity of the obtained carbon dioxide is a benefit derived by the addition of this additional step. The group of patents assigned to air product and chemical in which PSA processes for carbon dioxide separation from methane and or hydrogen are described. Carbon-based porous material, ACX or CMS, are in this case the preferred adsorbent. After desorption step, high pressure purge with carbon dioxide is followed by rinse and intermediate pressure with an extraneous gas such as air or carbon dioxide itself. The column is then subjected to vacuum to remove the extraneous gas or any remaining carbon dioxide. Additionally, Bourbon has demonstrated the effectiveness of CMS in carbon dioxide reaction from pre-treated LFG. Operation has been performed during the 1980s on two pilot plants located respectively in Germany and Holland. Unlike the process developed by the same company for nitrogen reaction by CMS, the inert rich stream is recovered as extract, and the methane rich stream, which up to 97% volume as raffinate stream. Thank you.
Therefore, as a conclusion, based on our previous discussion, we can see that PSA is a mature technology that are capable of removing various contaminants from the natural gas industries, an alternative to the energy-intensive cryogenic distillation.
So therefore, we can say that PSA is a very economically attractive option for investors to lower down their operating costs in natural gas processing.
Thank you.
Thank you.